Right. I'll give the standard statement that this is the last week before spring break. Next week, there is no classes, no labs, no scheduled office hours. You can still make an appointment to see me, but you'd have to make an appointment. I'm not available during the regular office hours. And I will be still answering my email. So, do that, send an email if you have any questions or issues. All right, now we're going to start having some fun, because so far we've dealt with a single entity at a time. Even in the first lab where I had you create an actor's entity to go along with the movie's entity, we really didn't link those two together. We had two entities, but they were pretty much two standalone entities. We haven't really done anything with relationships yet. So that's what we're going to talk about today. And we're going to talk about different kinds of relationships they are. We're going to spend a little bit of time talking about how they're implemented in a database, and then we'll spend probably most of the time talking about how they are implemented in our classes. Because remember, with the model first approach that we're taking, you define the model first, and that generates the corresponding database. So, simply put, there are three kinds of relationships. But practically, it's going to boil down to one. All right, that's the interesting thing. There's a one-to-one relationship. And it would be shown typically something like this. An example of a one-to-one relationship might be the example of head coach to sports team. Or, yes, the projector's not on again. 2 for 2 today. Relationship between head coach and sports team, right? A sports team only has one head coach, and someone is only head coach for one sports team. All right. The other thing you might think of is the relationship between dean and division. There's only one dean per division, and each dean only takes care of one division, and each division only has one dean. These are kind of rare. A lot of times you'll find, if you look at it closer, it's really an example of a one-to-many approach, or in some cases even a many-to-many approach. And that's the other two. There's a one-to-many approach. And an example of that might be customer and orders. And to tell this is called the cardinality. To tell the cardinality of the relationship, you have to look in both directions. One customer can have how many orders? Well, there can be many. Each order belongs to how many customers? It only belongs to one. So this would be an example of a one-to-many relationship. Relationship between professor and course or class, let's say. Each class has one professor, a professor that can teach multiple classes. So that'd be another example. It's important to look in both directions to tell, because sometimes you miss it if you only focus going in the one direction. By the way, counting in relationships, entity relationships, class diagrams, and database entity relationships diagrams is easy. There's really only 3 numbers to count, and you can count everything. There's 0, there's 1, and then there's many. All right. After 1 comes many. So it doesn't matter to say, like, for example, a teacher here typically teaches about 4 classes. All right. So you wouldn't build it and say, well, it's a 1-to-4 relationship. No, if a teacher could teach more in one class, it's one-to-many. All right. And you'd build a relationship that way. Finally, there's a many-to-many relationship. And an example for that might be the relationship between students and classes. Because if we go either way, we see it's many on both sides. So one student can have many classes, and a given class can have many students. So it's a many-to-many relationship. Now, here's where I said that it kind of boils down almost to just one kind of relationship, right? Because this is rare. I'm not saying you'll never encounter one, but these are kind of rare, and we're not going to really talk about them. You're definitely going to have one-to-many relationships, and many-to-many relationships have to be broken down, all right? In database terms, that is. They have to be broken down into 2 one-to-many relationships. In student and class. So a student can be enrolled in many classes. A class can have many students enrolled in it, but each enrollment record only relates to one course and one student. In other words, if this were a table, there would be a row for you for CISS243 and your student number. If you happen to take CISS232 as well, there'd be a second row for CISS232 and your student number, and so on down the line. So really, one-to-many is really what we're going to deal with most of the time. And again, there's also one-to-many or many-to-many come into play, but those usually get resolved into one-to-manys. The many-to-manys do. So this is an entity relationship diagram. Let's see if I pulled up another example. Oh, we could Google it. A number of different notations are used. I like this one, which I think they call the crow feet one, because those little things that look like sideways M's or W's kind of look like crow's feet, I guess. So what this is saying is that hockey game, this is a wacky database. A hockey game has a many-to-many relationships with team. I might say many-to-many relationships with team. Well, there's 2 teams, right? And remember, in database, we only count to 2. I would probably handle that differently, but I don't want to really get into that. Here's we're not going to look at this one. Change my mind. Is that any better? That one either. All right, this is part of one. Well, I'll tell you what, I won't spend time looking for one. They look basically like this, except with a lot more tables. All right. And they indicate the cardinality, the relationship between the two entities. Now, closely associated with entity relationship diagram, and possibly even more relevant to us, is a class diagram. Now, what is a class diagram? A class diagram shows the classes and how they relate to each other. And it's going to be very similar, right? But there's like a different slant to it. Because here we have a customer and has a one-to-many relationship to order. One customer has many orders. Each order only has one customer. But in this case, they talk about inheritance as well. And you typically don't see inheritance on an ERD. For example, in this case, it's likely or possible that there could, well, it could be, you could implement this one of two ways. You could have everything in an order table, or everything in an order table, and each one of these have their own tables. But this shows the classes that are inherited from it too. So if you notice, this, at least at the very basic level, looks a lot like this. Now let's talk about how we're going to implement this many-to-many relationship. So let's talk about customer and orders. All right. Talk about customers and orders. What do we want to store for each customer? We want an ID. We're going to keep this very basic. Name and email address, let's say. Keep it very simple. For order, we're going to have the ID, order date, and maybe some other things. Let's see, shipping address, and so on. Now we have to show the relationship between these two entities. So how are we going to do that, both in a database table situation and in our entities, which are just C# classes? We would do this in the database by doing this. We would have a customer ID in the order table. That implements the one-to-many relationship. All right. In other words, on the many side, we have a pointer to the one side, which makes sense, right? Because this can only point to one customer. If there's a customer ID in here, it can only point to one customer. So an order can only have one customer, and there's this ID number. A customer, however, can have multiple orders because they could have simply many orders that have their customer ID associated with it. So that's how you do it in a relational database. In our objects, we're going to do something a little different. So this is databases. Yes.
So in this, how would you show on the customer side there?
You'd use a query. You'd use queries.
So you'd query their customer ID.
Exactly. Yeah, depending on what you'd want. You'd join tables together. And we're going to do something very similar to that, except we're going to be attacking it from the entity side, from the class side. So but we're going to write very similar queries like you would have in SQL class. So this would be like a database approach. In our C# classes, or entities, or models, it's going to be similar to this, but it's going to be different. Let's get this on its own page. we're going to have, in addition to the customer ID in the order table, we're going to have a customer object. Which again, with most relational databases, you can't store objects. All right, there are object-oriented databases, but the kind of database system that is currently most used is a relational database where you can't really store objects. You have to do sort of a mapping like we're doing to map the objects to a database. But we're going to store in the order object, in the order class and order objects, we're going to store the customer ID and we're going to store the customer object. And in the customer, we're going to have a list of order objects. And you see it's a little bit different because here we can go right to the list of order objects associated with that customer, and that's how you get the orders. It's very similar. It's very similar in that it's a query, but the code is a little bit different and the approach is a little bit different. So for example, if I have a customer object named C and I wanted to know all of the order numbers and order dates. Say that's why I'm doing a query on the screen. I put in a customer number. I want to see all the orders they had and the order dates. What I would do is I loop through C's list of order objects. For each order, O, we would get O.ID and O.database, or database, sure. O.order date. And that's how we would query this, because the customer, if this is a customer has a list of order objects that we can loop through. After we've pulled this from the database, we can loop through that list of order objects. And for each element in that, the order ID is going to be O.ID and the order date is going to be O order date. Probably no spaces in between.
That would be faster because you're not querying the order database. You already have the list of order keys.
That'll be faster at the point that we're pulling these and displaying it, but you still have to get from the database to populate these objects. That's where the time would come into. That's where the lag of pulling stuff up from the database would come into. But we'll see how you can write queries to populate an object, all right, to populate all these objects. We've already seen basic ones, but those basic ones, there were no related tables. So that was simple. We just say, give me a list of contacts.customers, and that's it. Just give me a list of all customers. When we want to bring the order information in it, we have to specify we want the customers and we want their related order information. It does that because, again, sometimes when you want customers, you just want the customer information, and sometimes you want the customer and the order. So you specify what you want to fill in. Likewise, if we had an order object Q, if I wanted to know the customer name associated that, we would do something like Q.customer name. And that would pull up the associated customer data for the, if we retrieve the associated customer data for an order, we could ask for that order's customer and give me their name. All right, this is really cool because again, in the old days, which was not that far back, you did these queries using strings and pulled data from the database by having a string that had your SQL instruction. And the problem with that is there can be misspellings in a string. All that the compiler knows is that you got a string. Whereas this is, we're actually using object notation. If we do something like name, it knows that there's no such element called name with two E's. All right, let's look at this project that is one of the tutorials. So for this month, for week 8 and 9, review this video, watch this tutorial. And then here is the example. And then there's a video, I think, about the example. Oh, no, it's just another. I think I actually have 2 links to the same tutorial. All right, this is the Contoso University. And in the Contoso University, they have any number of entities. Let's take a look at the entities they have. And let's run it. We'll run it first to get an idea of what's in it. Then we'll take the time to look at the different entities in it, and then we'll look at the way that those entities are related. So if I run this, let's see what we got. If you were going to download this to your machine, you would download the code and you would have to update the database in order to see this, because you have to update the database, and you hadn't previously had this database there, so you'd have to update it. There's an about that shows, based on enrollment date, how many students that they have. Very small university, as you can see, 5 students. We have a list of students that we can create new, we can search, we can edit, see the details. Well, look at this. In the details, we show the courses that they're enrolled in. We have a list of the courses. And associated with each course is a department. We have instructors. And on the listing, they have a list of the courses that the instructor teaches. Likewise, if we look at details, it doesn't show it. But if we click select, it shows the customer or the courses that the instructor is teaching. If we click select here, it shows the students that are enrolled in that class. Finally, we have departments, which shows the administrator's name, and the administrator is the instructor. The idea is every department sort of has the lead person in the department. So there's an instructor associated with each department. So let's look at the entities that we have. Wish I could make this bigger. I don't know how to. We have the following entities. We have a course entity. Makes sense, right? We have a department entity. Makes sense. We have an enrollment entity. What's an enrollment entity? An enrollment entity is the intersecting entity between student and courses. Remember what I had drawn up a minute ago? I wish I would have kept it. The relationship between student and courses is many to many, right? One student can have many courses. A given course can have many students in it. Well, the enrollment entity is what handles that many to many. And we'll take a look and see how that is implemented, in a few minutes here. We have an office assignment all right, which that is like the office that a faculty person has. And then finally, we have a student. So let's look at let's start looking at courses. So we're going to review that from a couple different perspectives. Here's the course, right? Right, I lied a little bit. All right, we'll come to my lie in a few minutes here. But we have course number, which is an int, which the database is going to interpret as an ID, and it's going to interpret it as a primary key. We have a string for the title of the course, a number of credit hours, 0 to 5. We have a department ID and a department object. That's what I talked about before. We have a department ID and a department object, so that when we retrieve a course, we can retrieve the department ID associated with that. We retrieve the department ID associated with that course, but we also retrieve a department object that we can access the different attributes from the department. We then have two lists, all right? They say that you can have more than one instructor per course. So therefore, a list is needed for instructors. And they have associated with each course and a list of enrollment records. Let's look and see what's in that enrollment record. Enrollment ID, course ID, student ID, grade. And then associated with that is, in addition to the course ID, there's a course object. In addition to the student ID, there's a student object. Finally, if we look at students, we see this stuff: last name, first name, enrollment date. And then we see a list of how many enrollments that student has. All right. That way we've achieved the many-to-many, because a course has a list of enrollments, a student has a list of enrollments. If someone is enrolled in a course, there'll be a student object for that person in the course's enrollment list. And that course will be in the student's enrollment list. Now here's a neat little thing here. They've created an attribute named full name. All right. And there's no set method. Notice how this has a set method. Because there's no set method defined, you can't set the value of this attribute. This is a read-only attribute. And it's what we would call in database terms a computed column. Because really what the full name is simply concatenating the last name, a comma, and the first and middle initials, which I don't like. I would have a middle initial field separate instead of a first name. But anyhow. All of these have gets and sets sort of implied to where we can just set the attribute by assigning it a value. Here, a little mini calculation is done to or I should say operation. It's not really a calculation. An operation to concatenate those two things together. All right, so we looked at course, enrollments, students. Let's look at instructors. Sort of the same thing as students. And they have a collection of courses, and they have an office assignment object. And the office assignment object, I guess this is an example of a one-to-one relationship. That one instructor has one office has one instructor. Probably did that this way just to show an example of a one-to-one relationship. Anyhow, let's look at the relationship between courses, enrollments, and students on the database perspective. Now remember, you don't go in and make changes directly to the database. All right. We're using the model first approach, which means that if you wanted to add a column, you would add it to the model. So if there was something in the course that I didn't have, you know, I don't know what it could be, but if there was some attribute we needed to add to it, prerequisites, let's say, we would have to add it to this table or this entity, this class, and then we would update the database and the appropriate database changes were. But I think it's important to understand what's going on behind the scenes with the database. So I'll go in here, view, and select SQL Server Object Explorer. There we are, the school context. So let's look at the tables that it made. All right. It has made a course table. Makes sense, right? With the attributes in the course ID, the title, the credits. Now, a course is assigned a department. So there's the department ID in that table. Just as we said before, if you look at, excuse me, if you look at the entity, there's a department ID plus a department object. Well, there's no way to store a department object in a relational database, so all you get is a department ID. Enrollments. Has a primary key of the combination no, never mind. Has an index by by each of these IDs. I was mistaken. I thought I had a multi-part primary key. So there's an enrollment ID, there's a course ID, and there's a student ID, which again is similar to what we have here, but we don't get the objects in the actual relational database. Now here's something interesting. Let's look at the relationship between instructor and course. We had said before that there's a many-to-many relationship, right? Because an instructor can have a list of courses and a course can have a list of instructors. Now we don't have an entity named instructor course or course instructor, yet it created a database table. The modeling is smart enough to know that an intersecting table was required, so it generates a database table for this. And this one, I believe, has the combination primary key. Yes, of the course ID plus the instructor ID. Now you might ask, what is the difference between this and student and courses? They both have a many-to-many relationship. Well, these are two different kinds of many-to-many relationships. One of them, tables only represent the fact that there's a relationship. So in the case of the instructor, all we want to know is that this instructor teaches this course has these instructors. There's no additional information about the instructor course combination. Therefore, we don't need an entity for that. And in the database, you see all we have is primary key, just to create that. And all that does is establish a relationship between a particular course and a particular instructor. Now, in the case of students and courses, there is an additional piece of information. That is their grade. So we need to have a model for that because there's additional information. We're not just storing the fact that there's a relationship between students and courses. We're storing that there is a relationship and a student has a grade for that particular course. So that's why there's an entity for enrollment, but not an entity defined for course instructor. Now let's look at one of these pages. Let's find a good one. Don't you like, by the way, the Bootstrap? It's nice. Mobile compatible. Hamburger menus. All right, let's look at, I'm gonna look at instructor. No. Well, I want to look at student. Yeah. Let's look at department list. Excuse me. So I go to the department list. Notice what it has. It has the name of the department, the budget, start date of the department, and it has the name of the administrator. Now, the name of the administrator is a faculty member. All right. And when we go in to edit this or to add it, we get a drop down that we can pick the faculty member that is the person in charge of this department. We can change it. Now, notice that this shows from two entities. This is in the department or the instructor ID is in department entity, and there's a instructor object also in the department entity. So let's look again at the department entity real quick. Department entity has an ID, it has all this stuff. It has an instructor ID, and it has an instructor object that is named administrator. Okay. Now, let's look at the listing for department. Because you know that it pulled up not just the department information, but it pulled up the name of the instructor. There's no instructor name in this table or in this entity. There's an instructor ID, and there is an object of type instructor that we can pull the name from. So let's look in departments on the code behind. So we're getting our list of department called departments. We're getting it from the context departments, right? That's the database that contains departments. But oh yeah, we're saying we also want for each department, we want to fill in the department administrators. So we're doing essentially a query that joins those two tables together and brings them together. So when this is done, the department list contains a list of departments in which this object is populated. So now, when we go and list it, we pull out the headings and all that. we loop through each department in our list of departments. We get the name, the budget, the start date, and then we get the administrator's full name. So item is one of the, is the current item in the department list that we're looking at. And what do we want for that item? We want the administrator objects dot full name attribute. So that's how we join things together. We use the include on the query. Include is a method in LINQ that says, hey, effectively in database terms, it joins those two tables together. We can think of it in our cases, it's filling in those attributes. If we didn't do this, we didn't do this part, we would have a list of departments, but the administrator object would not get filled in. It only gets filled in if you ask for it, which again, as I mentioned, makes sense because sometimes you might just want data from the one table, in which case, why have all the overhead associated with joining it to other database tables and so on. But if you do want the data, this is how we can include it. Now let's look at the assignments that you have. Because this is a two-week unit, and spring break is smack dab in the middle of it. Your first assignment, and I misnumbered them. This should be 8 and 9, not 9 and 10. Well, I hope I don't worry people like what happened to lab 8. Is there something we missed? All right, you're going to create an application using identity. All right, so we're going to require login to change any of these. We're going to create a meal entity that contains this information, and we're going to create a category entity. All right, so the meal entity contains this, the category contains this. Now you need to implement this relationship. All right, what that means is in the meal entity, you need a category object. In the category object, you need a list of meal objects. All right, because there's a one-to-many relationship between category and meal. One category can have multiple meals. A given meal has one category. So the category ID is in this entity along with a category object. In the category entity, you'll have, along with these things, you'll have a list of meal objects. The biggest part of doing this is getting the entities defined correctly and getting the relationship set up correctly. Other than that, you're just going to scaffold the CRUD operations for both of them, put them on the menu so that I can add meals and categories. All right. One thing that I noticed is if you have a list of things, that list isn't going to be populated the first time you enter something. So therefore, I usually do something like this and say that it's optional. Yeah, make it optional. All right. Like in this case, make this optional. Okay, because that run into errors. I've run into errors previous semester with that. if any of you run into validation errors where it doesn't look like it saves, email me and I can walk you through fixing that. So the biggest part of this assignment is defining these entities correct, defining the models correct. The rest is simply practice of what you've already done before. Now, you're going to need to enter a category before you enter in a meal ID, right? Before you enter in a meal, because each meal needs a category. So you have to define the category first, and then you'll just use you'll probably, based on scaffolding, probably just need to use the meal ID. So the first meal that you add will be, or the first category that you add will be category ID of 1, and you might have to type that value in into the meals category ID. You might get a drop down. I've seen cases, and I'm not really sure what makes the difference of people that actually have gotten drop downs when they have done this. But either you'll get a drop down or you'll just enter the category ID number in. And that numbering is going to start with 1. So it will just go, the first category will be 1, second will be 2. And if you haven't deleted any, then we'll just go up from there. Now, the next part of this assignment will deal with, or the lab 10, we'll deal with when we get back. Feel free to look ahead if you want to, but, you know, hey, not a requirement. All right, that's all I had today. Have a good break. You can still reach me if you want to and need to, or either way. And we'll see you after the break. Great, take care.